Okay, from our last meeting, we have this problem of our assembly language. So the problem was the 45 minus 29 and plus 16 and minus 20. So if we have to change that one into an hexa, so we have the 2D minus 1D plus 10 or 10H, then minus 14H. Then if we have to change that into an assembly language, so the codes for the first theta, which is 45, is 0 LDE. So we have to load the 45 into your accumulator. But before you can load that 45 into the accumulator, so we have first to determine at what location in your RAM your 45 has been stored. So we have then to proceed to the next operation, which is the sub, and we have the add and another sub. So after this operation, this four operation, so we have to give the answer. So we have to have an out of code as well as the HLT to start the program. So the location of your 45 or 2DH in hexa is located at your 6H in your RAM. So therefore, your LDE or load to the accumulator the data at your 6H in your RAM. And the 7H is for your data 29 or 1DS. And that is also in your sub instruction. And we have the 8H for your 10H for 16. But also for the data 16 is on your line 2 or for the add 8H. And the last one is the 20 that is belong to the sub opcode and it is located at 9H. Then next, you have to change your assembly language to machine language. 0 LDE6H, that is equivalent to your machine language as 00 for your address 0, and another 000 for the LDE code, and 6H into binary in 0110. And you have 1H sub code is 0010, and you have the address 7H. And we have the add opcode, and the machine equivalent for add is 001. For 3H sub 9H, so we have other sub, and the location of the data to be subtracted is at 9H or 9 in binary. Then for 4H, that is out, we have to get the data output. Then for 5H, that is HLT to stop the program. So for your out and HLT, under the column address, the, the, the opcode being put in the address code is the XXX, or it means that is don't care. And for 6H, that is our 2D. So 2D in binary is 101101, and 7H is 1D. So we have 11101 and 10H. So we have 1000. The last one is 9H, is 1 and 4. So for the computer function of assembly language program execution under your SAP1, the first line or instruction that we have is that 0H, the address, and the instruction which is LDE6H. So that is, we have to load the data address by 6. So in terms of the table, for our one instruction, it consists of 6 T from T1 to T6. Then we have the PC, the program counter. We have the memory address register. We have the instruction register. the controller sequencer, the accumulator or A register. We have the base register or B register, and the last one is our output register. So under the first instruction na to, it is LDE, so therefore we have P1 up to P6. So what will happen to P1? So the equivalent machine language for our LD6X is this one. We have 00 address, LDE 000, 6X is 0110. So since this is the first instruction that we have in your SAP1 computer, PC has a value of 000. So at P1, that is your data from your PC will be go to your memory address register for decoding for the possible instruction what is being on that particular location. So therefore, your 00 will be go to the memory address register. At P2, that is increment. So it means you have to increment your PC from 00 minus yung 001. Then at P3, so we have now to locate the location in your RAM addressed by 000 and put that data or instruction into your instruction register. So if you have to look at your machine language equivalent, 000 has a value of 0000110. So at T3, that will be put at your IR. And T4, from your instruction register, we have to subdivide the 8 bits into 4. The first 4, which is your LDE, will go to your controller sequencer. And the address field of your instruction, which is 0110, will go back to your memory address register to get the data addressed by 6. Therefore, ano siya sa nakay data or address which is 6 as a data of 2D and 00 will go to your controller. So you have to get the data 6 which is 00101101. And since your controller is 000, that it means you have to load that data to your accumulator. So at T5, the data addressed by 6H will be at your accumulator. Then P6, this is no operation at all. So we call that one as NP. For the next instruction, it is 1H, is sub 7, equivalent to machine language sub 7 is equals to 001, 0010, 0111. Then at your table, we have now the data inside sa imong accumulator which is equivalent to 00101101. So, first T1, that is your memory address register. We have the value of PC, previous value of PC was 1. So it will go to your memory address register. T2 will increment that data in your PC, then it will become 1 at 0010. At T3, we have to get the instruction or data inside in your RAM addressed by 001. So that data is equivalent to 0010,011 or sub 7 will be at your IR. Then at T4, this instruction will be subdivided. The opcode will go to the controller and the address will go to your memory address register. So the 0111 or 7 will go to the MAR, 0010 will go to your controller. So The data addressed by 7 is 1DX, and the controller has an opcode which is sub. So your SAP1 cannot directly subtract the data from your RAM kung dili pa siya ibutang nato sa base register. So before we can subtract the data inside sa address na 7, first we have to load that data to your B register. So at P5, you have now your data which is equivalent to 1DH. Since it is to subtract, we have to subtract A and B. And the answer must be put back into A. And that is our P6. So if we have to subtract 2D with 1B, billing is 10. So that will be your P6 for your second instruction line. For the third instruction line, which is 2S, the instruction is add 8S. So remember that your accumulator has a value of 10, and the equivalent machine code of add 8 bits is 1 and 100. Therefore, also, the PC value that we have in our previous slide was 2 or 0010. It will go to the mark. At T2, it will increment. It now become 11 or 3. So get the data addressed by 0010 and put that into an IR. So therefore, IR has a value of add 8H. Add is 001, 8 is 100. Then your opcode will go to the controller and your address field will go to your address to get the data in order to add to your value of A. So we have 8, we have the data at 8 which is 10, and your controller is to add. So before we can add the data which is 10 to your register, to your E register, so we have to put your 10 to your B register. It is at B5. Then we add na sa A and B, and the answer will go back to your A. Adding these two, siyang 2D, 20. So that is the third line to 2H. In the fourth line, it is your 3H, is sub 9H. So remember that the accumulator has a value of 20. The machine code of 3H sub 9H is equivalent to 1100101001. The previous data of your PISA was 3 or 0011, and it will go to the memory address register. Then you have to increment your PC at T2 will now become 0100. Get the instruction addressed by your RAM with is 0011, which is equivalent to 9H as sub 9H. And so we have to put that one into your instruction register. Then get the opcode, go to the controller, the address file go to the memory address register. So the 9 will go to the MAR, and the 0010 will go to your controller. Then the data addressed by 9 is 14H. So we cannot subtract 14H from your A unless this 14H must be uploaded to your B register. So we have to put 14H to your B register. 14H is 0010100. So nana siya sa B register. Since your controller has an opcode of sub, so we have to subtract A with your B, and the answer will be put to your P6. So kung ato na siya i-subtract, then you have an answer of 0C. H or 0001100. And for your fourth line, fifth line, it is 4H out. So the previous data that we have in your PC was 4. It will go to the mar. At P2, it will increment by 1. Mahimo siyang 5. Then the data, it is, the address which is 4, equivalent to out. The instruction out will go to your IR. And the code is 110 that is out. And the next code which is XXX, that it means that is don't care. So we have no more. Data will go to the mar because that is don't care. We have only 110 that will go to your controller. So at your controller which is out, it means that the data at your accumulator will be put to your O register. So this A, which is 0C, will go to your O register. This your out. And for your line 6 with its HLT or 5H HLT, so we have this equivalent of code, machine code, which is 101, 1111, then XXX. The previous value in our PC was 5, then increment 5, it will become 6. Then the instruction addressed by 5 is out, and opcode which is 111 will go to the controller, and the don't care will go to the mar. So we have 111. So, so this code which is 111 is to end the program, and it will end the program with an output of 0C. So dili na siya pwede mo proceed sa next line which is 6H because the SAP1 computer function has now encountered an opcode which is HLT, meaning he has to stop the programming run or the execution run. So in all, this will be your equivalent table for that machine codes during your execution of your instruction. So we have the LDE, the sub, the add, the sub, and the out and HLT. It's all for Module 1 Introduction to System, Lesson 2 Structure and uh, do you have any questions?